Welcome to Askprep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of chemistry, which is chemical bonding, with a focus on two important concepts, VSEPR theory and hybridization. Whether you are studying for your Class 11 chemistry exams or gearing up for competitive exams, understanding these concepts thoroughly will help you master molecular structures and bonding. Let's begin with the basics. We all know that atoms combine to form molecules, and the way atoms bond determines the shape and properties of the molecules. Chemical bonding is primarily classified into three types: ionic, covalent, and metallic bonds. But today, our focus will be on covalent bonding, as VSEPR theory and hybridization are mainly used to explain covalent bonds and the shape of molecules. When atoms form covalent bonds, they share electrons to achieve a more stable electronic configuration. However, these atoms do not arrange themselves randomly in space. There is a specific pattern or shape that the molecule adopts, and that's where VSEPR theory comes in. The valence shell electron pair repulsion, VSEPR, theory explains how the electron pairs around a central atom arrange themselves in space to minimize repulsion. According to this theory, electron pairs, whether they are bonding pairs or lone pairs, will try to stay as far apart as possible. This minimizes the repulsion between them and helps determine the geometry of the molecule. Now, before we get into the details of VSEPR, let's quickly remind ourselves of electron pairs. In any molecule, the electrons in the outermost shell of an atom are involved in bonding. These are known as valence electrons. These valence electrons can either form bonds with other atoms or remain as lone pairs, meaning they are not involved in bonding but still affect the molecular geometry. In VSEPR theory, we treat bonding pairs and lone pairs as regions of electron density, and these regions want to be as far apart as possible. The number of regions of electron density around the central atom determines the basic shape of the molecule. For example, if there are two regions of electron density, the molecule adopts a linear shape. If there are three, the shape will be trigonal planar. 4 regions give a tetrahedral shape, and so on. Hybridization refers to the mixing of atomic orbitals to form new, hybrid orbitals. These hybrid orbitals are used to form covalent bonds. The concept was introduced to explain the bonding in molecules that VSEPR theory alone couldn't fully describe. Let's break this down. In an atom, electrons are arranged in different orbitals like s, p, and d. These orbitals have different shapes and orientations. However, when atoms form covalent bonds, they often do so by combining their orbitals to create new, hybrid orbitals that are more effective at forming bonds. These hybrid orbitals have specific shapes and orientations that allow them to form strong, stable bonds. The most common types of hybridization are sp, sp superscript 2, and sp superscript 3. Let's take a closer look at each type. First, sp hybridization occurs when one s orbital combines with one p orbital, forming two sp hybrid orbitals. These two sp orbitals are arranged linearly, at an angle of 180 degrees. This type of hybridization is seen in molecules like acetylene, CH, where the carbon atoms form a triple bond, and the molecule adopts a linear shape. Next, we have sp superscript 2 hybridization. This occurs when one s orbital mixes with two p orbitals to form three sp superscript 2 hybrid orbitals. These orbitals are arranged in a trigonal planar shape, with a bond angle of 120 degrees. An example of sp superscript 2 hybridization can be seen in molecules like ethane, CH, where each carbon forms a double bond with another carbon and single bonds with hydrogen atoms. The shape of the molecule is flat, and the bond angles are 120 degrees. Finally, sp superscript 3 hybridization happens when one s orbital combines with 3 p orbitals to form 4 sp superscript 3 hybrid orbitals. These orbitals are arranged in a tetrahedral geometry, with bond angles of 109.5 degrees. This type of hybridization is common in molecules like methane, CH, where the central carbon atom forms 4 single bonds with hydrogen atoms, creating a tetrahedral shape. the presence of lone pairs affects bond angles by exerting a stronger repulsive force compared to bonding pairs. For example, in water, the oxygen atom has 2 lone pairs and 2 bonding pairs, leading to a bent shape rather than a linear one. Similarly, ammonia has a trigonal pyramidal structure because of the lone pair on nitrogen, which pushes the bonded hydrogen atoms closer together. VSEPR theory is particularly useful in predicting the geometry of simple molecules, but for a deeper understanding of bonding, hybridization is essential. Hybridization is the concept that atomic orbitals mix to form new hybrid orbitals that facilitate bonding in molecules. This mixing occurs because atoms do not always bond using their original atomic orbitals. Instead, they combine orbitals of different energy levels to create equivalent hybrid orbitals that better accommodate bonding. For example, in methane, carbon undergoes sp superscript 3 hybridization, where 1s orbital and 3p orbitals mix to form 4 equivalent sp superscript 3 hybrid orbitals, resulting in a tetrahedral structure. This allows carbon to form 4 identical sigma bonds with hydrogen atoms. Similarly, in ethane, carbon atoms exhibit sp superscript 2 hybridization, forming 3 hybrid orbitals arranged in a trigonal planar shape, while the unhybridized p orbital forms a pi bond. This explains the presence of double bonds and their effect on molecular rigidity. As we wrap up, remember that both VSEPR theory and hybridization are fundamental in chemistry. Whether you are preparing for your 11th grade exams or aiming for success in NEET or JEE, mastering these concepts will give you a solid foundation in chemical bonding. Thank you. We hope this video has made these topics clearer for you. If you found it helpful, don't forget to like, share, and subscribe to Askprep for more such detailed explanations. Keep practicing, and good luck with your studies.